All right, well, we'll go ahead and get started. So thanks everyone for joining our webinar, Physical AI at the Edge. My name is Aristo Chang, and I'm on the product marketing team here at Archetype AI. For those of you new to Archetype, we're a foundation model company building AI for the physical world and understanding it in real time through sensor data. We have a great discussion today with our featured speakers, Jim Brisimitzis and Steve Broughton from Khasm Labs, and Sisinio Baldis from Archetype. A quick overview on Khasm Labs is they're an innovation platform specializing in private networks, edge computing, and AI infrastructure. They help enterprises, startups, and public sector organizations design, deploy, and operate real-world edge infrastructure that powers real-time AI connected devices and mission-critical operations. So I can't think of a better partner to join us for this webinar. Before we hop into the session and the discussion, we'll cover some housekeeping items. So first off is we will be recording this session and we'll share a copy of that over email once the session is over. And two, as questions come up, please feel free to submit them. You can use the Q&A feature in Zoom webinar to submit questions, and we'll have a live Q&A at the end of the session. Also want to note that there is a chat feature that we will not be monitoring. So again, please use that Q&A feature. So for today's discussion, we're going to first start off with some slides about Archetype and Edge AI. We'll then transition into the panel discussion with our featured speakers, and then we'll end with a live Q&A. So as a quick introduction to everyone, we're excited to welcome Jim Brisimitzis, who's the founder and general partner at Khasm Labs. Jim brings together enterprises, startups, and developers to accelerate adoption of next-gen technologies like edge computing, AI, and 5G. We have Steve Broughton, the chief architect at Khasm Labs, where he focuses on translating cutting-edge infrastructure and AI into real-world operational impact. And then we have Sisinio Baldis, the head of solutions engineering at Archetype, helping our customers realize value by deploying physical AI into their real-world operations. And you've already met me. I will be moderating the webinar. So just a quick overview on Archetype. We mentioned earlier that we're a foundation model company. So what we've done is we built Newton, which is a foundation model for the physical world. You can think of Newton as similar to an LLM, but in addition to understanding language and vision, it also understands sensor data. So it's effectively like a ChatGPT for the physical world, where you can ask Newton to explain what's happening in real time across all of your sensor data and make predictions on the states of your machines, your processes, and your physical systems. Newton is natively multimodal, so it works across hundreds of different sensors and can generalize to solve countless use cases across various industries and domains. All it requires is some basic prompting, few examples, and you no longer need to build and train custom models for every use case. We deploy Newton within our customers' infrastructure so that data never has to leave. They can fine-tune it, they can customize it, and turn it into their own foundation model optimized for their specific operations. We also provide all the tools to quickly build physical agents that can perceive and operate in the real world, that can run on-premise or at the edge. And for a few examples here, we've actually packaged up our most common use cases into pre-built agents. The first one is our process monitoring agent, which can detect anomalies and predict failures in physical assets and machines, as well as identify the optimal operating patterns to maximize performance like throughput, quality, or efficiency. We have a task verification agent that can monitor workers and their actions against standard operating procedures and track productivity. And then we also have a safety agent that can monitor physical spaces for risky behavior and adapt to any sort of rules or safety protocols you may have. So when we talk about AI that's running at the edge, what we're talking about are these types of agents that can be hosted and run close to where the action is, close to where that data is being generated. And so what does it actually mean to run at the edge? Well, there are several patterns here that we want to go over quickly. First one, on device, something that I think a lot of us have seen or heard about, where the inference runs directly on the machine. Think industrial machines like a wind turbine, think cars or robotics. This is where you want AI to operate without external dependencies. As we move to the right, the on-prem edge server. You can think of this as a local server that's running at a specific site or a facility. This server will process data from multiple different machines without any sort of dependencies to a cloud. And then as we move again to the right, we have the telco edge. This is where processing and AI inference actually occurs in the telco cloud, where essentially there are distributed edge data centers that will run closer to where your operations are running. So similar in concept to the cloud, but running much closer to where you actually need it to run. And then there are newer mediums coming out like the radio network, where we can actually start to run AI inference on cell towers. And so why are we talking about this? What are the benefits of running at the edge? Well, the first one is around real-time, low latency response, where you really need that for critical safety, autonomous operations, any other real-time experiences. We have connectivity. So when you may be dealing with situations where you're bandwidth constrained, you have remote environments, or you just need high uptime and you want resilience, you want AI that can run locally and isn't dependent on any external sources. Data security as well, where you may have sensitive information, IP, that just can't leave your premises and you want to process it locally. And then cost efficiency, when you start to work with large scale amounts of data, video, and you want to be able to process it locally so you don't have to continuously stream all that information to the cloud for inference. So we wanted to share a quick example here of a project that Khasm and Archetype both worked on with the city at Bellevue to improve pedestrian safety. This is where we actually deployed at the telco edge to monitor incidents in real time through existing traffic cameras. And as you can see here, this is the interface. You can see that we're actually monitoring video feeds live across different intersections and bringing in information like the crosswalk status. And then in real time, we are identifying real incidents, like in this case, this pedestrian that almost got hit twice despite having the right of way. And in aggregate, we can start to understand where are these incidents happening, how often are they happening, and how often are pedestrians crossing when maybe they don't have the right to walk based on the signals, and identify a lot of these peak crossing times and get insights to improve these systems. So with that, I will open up the discussion and pass this along to Steve. And Steve, we'd love to hear more about this project and what we achieved and what we learned from it.
All right. Thanks, Aristo. Yeah, it's a fascinating project, actually. If you think about the vision of what Aristo just showed, there's a really high ceiling on this because not only can we learn a lot, like you mentioned, how frequently do these sorts of things happen? You'd be shocked. I've learned that jaywalking happens a lot less than I thought, and incidents like you just saw happen a lot more than I thought. So it's having a 24/7 watcher out there is really fascinating. But it can provide a couple of really critical things. Number one is just knowing if an event does happen. What happened if that car actually crashed into that bike, right? And could you, at the end of the day, could you alert emergency services and then provide some situational awareness through a clip of the video, shows what the situation is, how much traffic is there, how much, was it a big impact to the pedestrian and so on. So the vision is, yeah, it's got a really tall ceiling. Now, where are we right now? Currently, we just like that camera you just saw, we're watching a couple of intersections in the city, and we're looking specifically for pedestrian situations. So we focus less on cars and more on people. So slow crossers or people who cross late or that kind of thing, large crowds. And one of the benefits of using the archetype model is number one, you can look for a wide variety of behaviors, but then you can also take in multiple kinds of sensors. So not only do we have the camera input, but we have the traffic control system that's talking directly to us, streaming many times a second the state of each traffic light. So we know exactly where in the cycle things are. And when we see a situation where a pedestrian is going to be in the intersection when the light turns against them, we can take some actions. It's an agentic system. We learn from the archetype system, and then we are able to send signals to the intersection. Hey, well, one is we can extend the walk sign, like if you have the regular walk sign going, and we can just say keep it on longer. Or if it's too late for that because it's already flashing the red, we can say, hey, okay, go ahead and complete that. But what we're not going to do is allow the red light to change. So we're going to hold opposing traffic until the pedestrians are safe. And so that's effectively what we're doing right now. Um, it's provided a good number of lessons to us. The first thing to note is there's multiple ways to go about looking at an intersection. We could use different sensors like LiDAR and so forth, but we were talking about the edge and what the edge means. If I were to deploy a really high bandwidth kind of solution like LiDAR, I probably have compute at the intersection. That is, I don't think I've seen it deployed any other way. So you do that, and if that's what the solution needs, that's what the solution needs. But there's this economic spectrum that you can look at and say, can we do it differently? And so what we set out to do is to look at this whole thing as a system rather than a location. Does the system, based on the bandwidth needs and the speed of the transaction and the context and the economics, can we do it differently? Can we use video for one thing, which oddly is a lot less heavyweight than a 3D LiDAR? And then, and we have or the signal phase and timing that we can look at. Can we do it differently and deploy not necessarily in the intersection, which would be the far, far, far edge in Aristo's diagram, but we're going to pull it back not just to the on-prem data center, but we pulled it back one more. We're still very close because if you think about it, when you leave an enterprise, the first thing you hit is the telco, right? It's right there, and it's extremely distributed. And so we said, can we do it there? And the short answer is yes, because it turns out we do have some time budget. And so, pedestrians, for example, don't actually leave when the light turns white and go, it takes them a second to like start, which is really annoying when you're someone who's worried about latency. But we do have a little bit of a window to work with. However, when we need to make a decision, we need to make it really, really quickly. So latency is a critical component, which is why we elected not to pull back further into the cloud. It's the telco is required because when you add just a tiny bit of latency, and we just tested this a couple of weeks ago with Sisinio's team, the if you add just a little bit of round trip latency, and it's not much, it's tens of milliseconds, because of all the round trips involved, we declined in our performance 15%, just like that. And it was a tiny incremental addition to round trip latency. So it turns out it's really, really important. You're going to miss the moment where safety matters. So we found that we could be close enough by deploying the inference in the telco network. We have 5 milliseconds of round trip latency, which is really good. But I also want to point out that this is on a wire. Another lesson learned is don't assume that if it works on the wire, it's going to work in a mobile network because the architecture is completely different, particularly in a public network. So what works on the wire, not necessarily, on wireless. I should also point out, though, that when we think about the continuum of the solution, it's not like we're replacing the cloud. It's not like we're deploying at an edge and replacing cloud. It's all about what you want to do and where. What decision are you making at any given point in time? For example, we need to be close to the intersection to make a decision about whether or not we're going to extend a light or take some other action. But there's a ton of post-processing that happens as well, and there's model training and AI lifecycle functions and so forth. And those things still live in the cloud, and it's part of the system. So I think the overall summary on lessons learned here is that yes, latency matters. It absolutely matters and is critical to the operation. But please appreciate the entire system and evaluate where each decision needs to be made, because a decision about someone crossing needs to happen just like that. But packaging up a video and sending it to 911 services, you can take 10 seconds for that, right? So that's a totally different paradigm. So just think about the system in whole and what needs to go where.
That's great. Thanks, Steve. It's great to hear about all those, different use cases that you're looking at and how and where, you can think about deploying and what makes sense based on the entire system. So thanks for sharing that. So next, I want to pass this off to Jim, because Jim, you've been working at the intersection of edge and networks and AI for quite some time. Would love to hear about what's changed recently that made what we just saw, that physical eye at the edge, and what's made that viable.
Yeah, a great question. And just to build on what Steve was sharing, it's pretty clear to us, and I would assume it's also clear to the Archetype team as well, that as enterprises continue to explore and adopt AI, their AI is only as good as the data that they have. Most of that data, according to Gartner, Forrester, and other analysts, unfortunately does not reside inside their public cloud instances or private cloud. That data is on the edge. What City of Bellevue signifies is more than just an intelligent signaling and pedestrian safety system. It is about taking advantage of data in real time where machines can make agentic decisions on what they're seeing. Today, it's pedestrian safety with City of Bellevue. Tomorrow, it could be many use cases in the utility sector or energy sector or manufacturing or others. So for us, it's a foregone conclusion that enterprises will continue investing in AI. There's no question. And they're only going to be limited by the data that they have. And for them to truly adopt something that's agentic, a system that is agentic, they're going to have to figure out how do they get data from the edge into their models in real time to be retrained and inferenced, have that data inferenced and retrained against their models for then agentic actions to happen. And I'm really proud of the work that we've done with Archetype. And it has to go without saying that this isn't just about bringing smarts into intersections. For the very first time, we've taken Archetype together, we have solved not just the agentic play for pedestrian safety. We are starting to create the roadmaps for the telco edge as well, and that should not be lost in all of the conversations that we've had. When's the last time you've heard of a telco actually running AI workloads on their edge? And we're doing it for the first time with Archetype, so I'm really, really proud of that. So just to close, there's a whole slew of use cases out there. The data is critical. That without that data in play, I find I find that enterprises will be hard pressed to really realize the true potential of AI with just the data that they have. And so we're not just pioneering pedestrian safety, as I mentioned. We are starting to lay the foundation of what it would mean to take similar approaches, similar systems, as Steve's rightly pointed out, and apply it to new use cases in other sectors. And Sisinio has done a great job with other sectors. I don't want to steal his thunder, let him speak to some of those use cases. But that's what we're demonstrating here. And what we have seen, and Steve, I think, would back me up on this claim, when we first approached the City of Bellevue about this particular use case, their feedback was, yeah, latency is not all that important. And then we got to a crunch point where our latency performance was actually higher than what they needed the models to be able to predict at. And so, together with Archetype, we refined the approach and maximized the performance of the platform and met those requirements quite easily. So, many enterprises will start to realize that in certain use cases, for instance, in utility use cases where you have an overabundance of demand because of EV charging, and you're going to saturate the grid with demand, and you'll need to reroute energy distribution to meet that demand. You don't have time to just provide analytics to some operator to let them decide. We physically trained a model to make decisions based on the parameters we've told it to operate within. And now systems are actually making intelligent choices based on whatever the use cases are demanding for. And that's the exciting part of where AI is going, as it truly helps enterprises do more and be able to react more to the real life, to the real time.
Great. Yeah, thanks, Jim.
Yeah.
Next, I want to move this over to Sisinio. So, Sisinio, what's driving the movement to the edge, and what types of use case patterns are you actually seeing emerge with customers?
Yeah, thanks, Aristo. I'm going to probably echo a lot of what's been said already. But the AI and analyzing, the physical world, brings on a whole new set of challenges. I think by now most of us are pretty familiar with, interacting with, frontier models to do text-based AI to, the physical world presents a lot of challenges to that. We've spent, the past like decade plus, we've been consolidating compute into the cloud, right? So, and now we're talking about the hardware has gone up in capability. We're adding GPUs to the cloud, but the physical world is where the physical world is. The physical world doesn't live in the cloud. So you really have to bring, physical AI. AI has to go to where the data is, and that's where the devices, that's where your assets are. They already have, or assets in the field already have a perception system. And amazing about, physical AI is there's an infrastructure that's been built up over, decades and decades. Um, Assets with all kinds of sensors on them, brownfield installations, ones that are pre-existing, with an enormous amount of sensing perceptual capabilities, but we're really not gleaning a lot of intelligence from that. We're using fairly primitive forms of like machine learning algorithms or even more thresholding analytical types of things. And those things work well in certain settings, but they're not generalizable, right? And if you talk about some of the issues, you'd asked about, and you'd brought them up in one of your earlier slides, folks at Chasm had touched on like latency, matters. Like if milliseconds matter, you have to go closer and closer and closer to where the data is being collected. And what's interesting about edge AI, the edge to me is like, you think about an onion, right? If you at the closest orbit would be right at the device, right on the sensor. If you could embed AI right on the sensor itself, that's probably as close as it can get. And then you start to move away from it. Maybe it's on a factory floor. In the case of it could be, at a traffic light system. It could be at a telco edge. It could be at a radio access network. It could be in a data center. And eventually you'll make it up to the cloud. Connectivity is a huge one. We typically have to assume that offline is the norm in a lot of cases, right? So we have critical assets. Um, the You can't rely on loss, or you can't suffer any losses, right, in connectivity. If you have critical infrastructure, it's in the field, it might be completely disconnected. If it's underground or underwater, even in a manufacturing facility, or imagine a hospital setting where it's critical, you might have backup generators, but if the network goes down, if there's a power outage, you have a backup generators. You can't make inference if you're running, and if your connection is severed. So if you have the ability to bring that inference into something that you control, whether that's actually on site in a field, in gas and oil, or on a manufacturing facility or a distribution center, or even in a smart city or airport, then it gives you a lot of control. And then data is heavy. There's a lot of data gravity, right? Like these sensors are each generating an enormous amount of data, right? So you have these fire hoses of data being generated. Like, we're talking to folks that have dozens of sensors, but we're also talking to some that have hundreds. And in very large installations, you could have thousands of sensors generating data anywhere from, hertz, frequencies of minutes, seconds, or, kilohertz, right? That's an enormous amount of data. AI has a compression ability too, right? You can take an enormous amount of data, you compress it down, you end up with an intelligence event, and those can go upstream. And again, based on an onion, you run inference where it makes sense, and that also bleeds into what people have talked about cost as well, right? If you can distribute your inference to run it at the cloud would be your most expensive place to run it for many things in terms of moving data, even the cost of compute. The closer you can move that to the actual device, the better. So there's all types of different things, and that kind of leads into the use cases that you're talking about. Like we're being able, we have a lot of interest in some of the things that Chasm is doing and kind of like smart cities, where you do from a safety perspective, we're talking similar kind of use cases in airports where you have a lot of sensors out in the field. You just don't have enough humans to actually understand the data, right? That mismatch is a perfect blend of where AI can augment, right? So AI can do the lift of analyzing the data and surface the events that are important for people to take action on. But then also one of our biggest areas is in process monitoring, and that spans everything from our like oil and gas clients where they have drills that are drilling underground, um, and industrial facilities where they have all types of machinery that's working. They also have video as well. fleets. There's fleets out there that we're well familiar with. Self-driving cars are coming online, but if you take a look at the number of fleets as assets where they have to go into a maintenance cycle, and understanding, how to optimize those maintenance cycles, things like HVAC systems. There's industrial and commercial HVAC systems. It's a very big concern for enterprises, right? How do you optimize the downtime of any of these things? And we were just at a massive distribution facility last week. They have these machines that are moving packages at these tremendous rates. They have a maintenance windows of like 4 hours a day where they can do their maintenance. But if this thing breaks down at any other point during the day, the packages just start to fill up, and backlog. So there's just all of these types of capabilities that we can do by bringing edge our AI right to the device, right to the device itself,
Hey,
right as
Risto,
close
do
as it needs.
you mind if I chime in on a point that Sisinio made before you ask your
Yes.
next question? Sorry to go
Yeah.
off script, but
Please,
Sisinio
please do.
brought up a really great point about data gravity. The City of Bellevue today, it's one of several examples we know, but City of Bellevue today has 220 intersections within the city itself. Those intersections each have cameras for which we are feeding into the archetype model. Each of those cameras will generate an aggregate of 16.918 petabytes of data a year. And so Sisinio touched on the inferencing on the cloud being the most expensive thing, and he also touched upon transport. Transport cost, if Bellevue were to move this to any cloud, to simply inference, that just the moving of it is somewhere between $850,000 to $1 million a year, with no action taken on the data whatsoever. So data gravity is a key point that Sincere rightly pointed out. Enterprises don't need to move that inferencing to some centralized cloud. It could be their own private cloud, public cloud, or a combination of, doesn't matter. They need actually the ability to inference closest where the data is, not to just address that cost of transport, but the real-time stuff that comes with that, the ability to actually now action on some of those use cases that Sisinio talked about. That's where the true value is. The benefit and the bonus is you're not spending gobs and gobs and gobs of money to just simply move data to go inference. Remember, you're taking petabytes of data and you're looking for anomalies and inferences and then using those anomalies to retrain the model against that. So you're moving truckloads of data really for portions, very small portions to be used in the retraining of the model and fine tuning it and then taking agentic actions on that as well. So for anyone who's listening in and thinking about their agentic enterprise and their AI strategy, this is not just about this cost savings. This is about you're moving the right data workloads from inferencing closest to where that data gravity is, so you can actually inform and retrain and fine tune those models in real time to then take actions on the limited capabilities that humans do have, given there's so much of this real-time data coming in from systems across any industry. That's really key here. That is super key. And I think that's a big reason why maybe outfits like the City of Bellevue or other enterprises have not really taken advantage of the data that they have on the edge. It's just simply too expensive to move. And not only that, you could have the best fiber. In fact, all of the intersections we connect to in City of Bellevue are fiber-based. So you can have the best fiber network on the planet. Physics is physics, right? And if you have large amounts of data, it's going to take time to move that to any cloud. It doesn't. You can't change that. And so anyway, Sisinio, sorry, you touched on something on data gravity that I failed to bring up in my earlier comments, and I wanted to make sure that the audience heard that is a critical point here. It's really, really important for enterprises as they think about AI on the edge.
Yeah, thanks, Jim. Yeah, that's great. Yeah, I think as you start to go on your journey in physical AI, these types of issues definitely become
100%.
very apparent. Yeah, yeah,
And securing it too. Yep.
yeah. Back to you, Aristo.
Yeah, great. Thanks. Yeah, it's a great point around what you can actually do now that you can unlock that data for the first time. All right, so for this next question, I want to kind of dive more into some of these real world learnings. So actually want to pass this one to Steve. And Steve, for the teams that have already built successful AI in the cloud, what do they need to be ready for when they try to deploy similar
Mm.
capabilities, but at the edge?
Excuse me. Yes, that's a great question. It's sort of loaded, but on the back end, the benefits are worth it. Trust me. The biggest shift really is in what you're optimizing for. So the cloud lets you optimize for capability. Like, it's ubiquitous compute. In theory, there's ubiquitous connectivity, centralized data. It's all there. But when you move to an edge scenario, you do so because you have some constraint. So now suddenly you are optimizing for constraint rather than capability. So the assumptions of unlimited compute and so forth, all this stuff needs reevaluation. For one thing, you're much more aware of where the compute is. If you're coming from cloud, that is, you're more aware. The cloud's this big nebulous thing, but the edge is necessarily about placement. Where is it? You're going to know where it is, and the devil is in the details. Also, what kind of hardware is it? You become very aware of what hardware is supporting you. It's not. You still might have a cloud-like service, like if you're in the telco network, you still might be able to select, what kind of inferencing hardware you're using, for example. But if you move closer to the data, the closer you get, the more aware of the hardware you're going to get because it might be you deploying it. So that's a big one. You have a much more granular understanding of the connectivity details as well. And Sisinio kind of went over this, but um, what happens if connectivity breaks? Because when you think about the end-to-end system, inference is one piece of it, and that's where the action is, right? Your agents are there, the inference is there. But generally speaking, almost everything has a back-end connection to something. And what happens when that goes away? Or what happens if there's a link? In the case of the telco network, what happens if our telco AI inference system loses touch with the camera out at the intersection? So there is a default state, like Sisinio said, that you need to be very careful about how you deploy that. Um, the decisions about what data can go where, I won't belabor that because I think Sisinio and Jim have covered that really, really well. But you do have decisions to make about what you propagate from the inference system into the cloud, for example. What do you dump? Like in the video system, we get rid of as much as we can. And then we send only the meaningful parts back into the cloud. So outside of the telco scenario that we're very familiar with from this traffic solution, the closer you get to the edge, the chances that the inferencing environments are not uniform also increases, right? So there may be some inconsistencies out there, and you may or may not control all of the hardware depending on if you're in the data center versus whether you're on the excavator. So there's a whole bunch of other things to think about in that regard, and therefore it also changes the operational, the overall operational model, and maybe finally you can think of observability, right? So whereas if you were operating in the cloud, you have this nice central dashboard. But now instead of a central application, you have a distributed system. And so visibility, knowing what resources are online, what's broken, the status, it's kind of it's an extra element, I guess, in terms of visibility. And I say all this stuff and it sounds complicated. It might be less complicated than I make it out to be because the needs make themselves apparent. But I will tell you from our experience with Archetype and the City of Bellevue, once you get over these hurdles and have the understanding of this distributed application that you're rolling out, the functional benefits are palpable, and the economic benefits actually, even in the case of the traffic cameras where we can aggregate cameras, the economic benefits there are also palpable. So. Yeah, that's it in a nutshell.
Great. Thank you, Steve. Actually, Jim, I want to pass this next one to you. We'd love to just hear, what advice would you give to anyone looking to deploy an edge AI project?
Great question. So when we started our journey with Archetype at City of Bellevue, we went to them with what are your most pressing use cases? Like what are the hardest things you guys want to go solve? And it turned out, as luck would have it, the City of Bellevue had been awarded a grant from the Department of Transportation around pedestrian safety, and that was high on their list. There's other use cases that are also high on their list. So for enterprises that we've spoken to, and Sisinio may have seen similar engagements with Archetype, there is such a wide there's such a wide aperture of where enterprises want to apply AI. They just haven't really prioritized what are the highest pain points. When you can prioritize your highest pain point, and go solve that problem, the lessons and the methodologies and all the other fun stuff that you've learned from solving that one pain point can then easily be translated into others. And we're actually doing that today. Steve mentioned this earlier in his earlier question. Today, we're managing pedestrian safety, but in future, we're going to be rolling out more capabilities that can identify when an accident has happened, annotate that accident, and then pass it along to an E911 dispatch so they can verify, yes, we need to send police, fire, ambulance, or some combination thereof. So that's where we've started. And in fact, we've had several conversations with utilities, energy providers, manufacturers, logistic providers around what are their highest pain point issues. And then from there, use those as cornerstone use cases to not just solve those particular pain points, but then continue on the same methodologies to go and solve others. On the utility side, there's use cases from vegetation management to monitoring substation systems. As I mentioned earlier, utilities used to have a pretty easy job. They would manage load distribution across the grid, and it was pretty predictable from one day to the next. And then all of a sudden, the EVs came on market, and more people started deploying solar, and so there was a lot more demand on the grid, a lot more coming into the grid, and what was normal patterns then don't necessarily apply today. So being able to help them monitor substation activities is more than just predictive maintenance on systems. It is about in one given cluster of a community, you could have 40 EVs that are charging all at the same time. They'll overwhelm a transformer and blow it. So we're working on use cases in the utility space for that. Steve and I had a great conversation with the chief operating officer for one of our logistics clients, where it sounds like a simple use case. It's around scheduling and making sure that truckers are showing up on time and picking up or delivering containers. The ramifications for that is hundreds of thousands of dollars of revenue every day for every minute lost in productivity and lifts and everything else. And so we're starting to solve problems with them on that. But anyways, just to take a step back, if I were an enterprise today trying to assess where do I best apply AI, go look for your hardest problems. And then start to create the solution engineering around how AI could play an effective role in doing that. And in doing so, learn quite a bit. We're one of the first entities working with Archetype in the world to go deploy edge AI inside a carrier's network. And there's a lot of methodologies, a lot of things that I think I can say on behalf of both Archetype and Khasm Labs that we've learned together. For the first time, we're actually putting a system out on the edge inside of a carrier's network that is not cloud, and it's communicating with the cloud. And we're now interfacing with local devices, some of which are IP based, some of which are OT based. And so we've learned quite a bit. Those methodologies are really important to enterprises as they deploy those early use cases, because those patterns will be helpful as they go address and deploy additional use cases as well.
Thanks, Jim. Love that approach. I really appreciate that.
Sure.
I know we have just about 5 minutes left, so I think it's probably a good point to transition to the audience Q&A. So I'm gonna just take a look at the Q&A screen right now, and if anyone has any questions, continue to submit them. This first question here, I think, would be a good one for Sisinio. So the question here is, can we explain how the foundation model actually helps resolve these problems? I think this is in reference to the Bellevue use case. And what is the added value to a conventional AI detection and classification on video data? So what is a foundation model like Newton helping add value to compared to traditional methods? I think maybe one thing I'll just call out before I pass it over to you, Sisinio, is a foundation model like Newton will be able to generalize to a lot of these different events that's actually coming through this video data. And one thing that was called out before too is not only are we looking at this live video feed, but we're also bringing in signals from other types of sensors. So we're bringing in information from the crosswalk. If there was a LiDAR system, we could take in LiDAR as well. So we're able to bring in all these types of modalities into one place to make an inference on top of that. But Cecilia, I want to pass it on to you to see if there's anything you'd like to add.
Yeah, no, great question. A lot to unpack there. And just, I think it's important to frame what a physical AI foundation model is different from what most people are used to kind of as they're working with the frontier models, large language models like OpenAI or Anthropic. The the history of OpenAI and what the problem that they're solving is similar to what physical AI solves. We used to have very simple like machine learning algorithms to do like semantic analysis, like on a few words, right? And it took a lot of training to understand like, oh, this is a positive thing, this is a negative thing. And you had to include humans in the loop to train that. What was novel and the fundamental shift was now what the GPT types of models, they trained on the entire world of language. And by doing that in a large enough neural network, these emergent properties came out of these neural networks that allowed you to understand language without having to train for very narrow things like a use case like sentiment analysis. So if we now switch over to physical AI, the same shift happened. We've been doing threshold analysis of signals forever. Then we migrated as more and more data was available and research into machine learning, where we started to take very narrow use cases, a lot of data and a very specific sensor or maybe a couple of sensors to do an analysis and maybe classify that into a couple of states. What we found is that breaks very quickly because physical AI, the physical world is extremely messy, right? Um, it doesn't matter what you're doing, what the application is, the assets that you're using have different sensors on them. The sensors themselves have different qualities to them. They have different ages. The machines themselves are degrading. Anyone that's ever driven a car for more than 1 year realizes that the car that they bought feels different 10 years after they purchased it. And that's because fundamentally the system is degrading over time. But it still feels like a car. It just feels like an old car. And this you can use the same analogy to driving a Toyota uh, or a Mercedes or a pickup truck or a delivery truck. They all feel like automobiles, but they all feel very different. Now, machine learning algorithms are really bad at migrating from an old car to a new car to a pickup truck to a sedan to a delivery truck. You apply that same thing to a drilling site where you're drilling underground. The terrain is different in every single place that you're drilling. The drill configuration is slightly different. The sensor package that you're using is different. The machines are aging over time. The temperatures are different. The physical world is messy. A foundation model, we've trained the model on a world of physical data. So statistically, it can generalize its emergent qualities in the model to give you this capability to take this one model and apply it to different sites, different assets, and generalize. And we can optimize. We have all these dials that we can provide as part of that. But yeah, that's the fundamental difference of a foundation model versus like a narrowly trained model that we're used to seeing.
Hey, and Aristo, again, going slightly off script here, I just want to double down on what Sisinio said, like 100%, 110%, because I get this question a lot, like, oh, it's a camera, it can tell there's a person there, like, what's the big deal? And in fact, I've had someone demo a product to me to say, "Hey, well, here I have this camera, and look, I can classify this human really quickly," and so on. And I'm like, okay, that's great, but what happens if that human is having an argument with somebody, or or actually collides with a car or whatever? Like, can you do that? And suddenly, it's a totally different problem to solve, right? Something that a point solution is not going to get to, but the archetype solution is going to address in full.
Thanks. Yeah, that's a great point. That's a great point. So thank you, Sisinio and Steve, for that. Excuse me. I know we're at time, but I do want to make sure we get one more question in here. I think this one is a more practical one that I think would be great for Steve and Jim here. The question is, when you have these systems in the field, how do you think about updating them so that you can prevent downtime or regression? I guess maybe what is your approach or process to actually upgrading these systems in the field?
Oh, this one's easy. Steve, you want to go for it?
Well, I'll go into the weeds. So no, Jim. I mean, I have the answer.
Okay. It's easy because it's the cloud, meaning there is a link between the cloud and the edge. the models that are inferencing and the inferencing models themselves are updating via the cloud. Unlike some of the LiDAR-based systems that Steve had mentioned earlier in today's webinar, those have physical edge systems that actually sit in the intersections. And by the way, those are $30,000 to $50,000 per intersection. Do the math, very expensive. And so in what we've been able to do, it's fairly straightforward. We've created our own systems to be able to manage that. Ultimately, we want to see that fully automated in the future. But again, we're kind of breaking glass here and doing something that no one's really tried to do anywhere in the world. And so from that, we have entirely embraced the cloud model, which is we can over time automate and make sure that whatever systems we do run on the edge are as updated as the systems that they're talking to in the cloud. That is my marketing speech, and I'll turn it to Steve to talk about the architecture side.
Yeah, and I know we're up against time, so I'm just going to go really fast. I think unfortunately, this question is really use case dependent because like some things can have like zero downtime. Like you're looking at millisecond level, and so that's one problem to solve. In our case, how we're managing is that everything that we do is microservices based. So the model runs, and if the model needs to be taken offline for any reason, and since we were doing a proof of concept, that did happen a few times. It's do it in an outage window at 4 a.m. when no one's crossing the street, right? So it's fairly straightforward that way. But everything else is microservices based, and so we can take a service offline for a second, and it's not going to impact anything as it relates to the intersection. So the microservices architecture really is critical for us because we don't have to take the system down. We might take a service down, or we might refresh a service, but we have the updated service ready to go, and it's just a very quick update. You're down for a second, and you're up. So that's how we're managing.
Fantastic. Thanks so much, Steve. Thanks, Jim. All right. So wanted to switch gears because that's all the time we have for today. So again, thank you everyone for joining. And thank you so much, Jim, Steve, and Sisinio for this really great conversation.